Section 9.4 Hypothesis Testing for the Means. For these sessions, we conduct a hypothesis testing for the population mean. Remember the 4 steps of hypothesis testing? First one, hypothesize. You're gonna state the null and alternate hypothesis. Prepare. We're gonna find the test statistic and then check the condition and assumption. Number 3, compute to compare. Choose the significance level and compute the test statistic and the p-value. So for this class, significance level is always be given. Okay, and then we only need to find the test statistic and find the p-value. Last one, interpret. You reject or fail to reject the null hypothesis, and also you want to state the conclusion. Just as with hypothesis test for the proportion, hypothesis test can be one side or two sides depending on the research question. The choice of the alternate hypothesis determines how the p-value is calculated. So same idea, we do have not equal to, strictly less than, strictly greater than. Okay, not equal to, there'll be two sides. Strictly less than, there'll be left tail. Strictly greater than, there'll be right tail. Test statistic for one sample t-test. So this is the formula for you guys finding the test statistic. If the condition holds, the test statistic follows a t-distribution with, we do have a degree of freedom, okay, n-1. And then two conditions, random independent sample and large sample. Sample size must be at least 25. Okay, this is the instruction. Follow the instruction to use your calculator to find the p-value. Okay, let's try to do it together. In 2010, the mean years of experience among a nursing staff was 14.3 years. A nurse manager took a survey of a random sample of 35 nurses at the hospital and found a sample mean of 18.37 years with a standard deviation of 11.12 years. Do we have evidence that the mean years of experience among the nursing staff at the hospital has increased? Use a significance level of 0.05. Okay, so we are working on the population mean. And then, with this sentence again, the mean years of experience among a nursing staff was 14.3. So this is going to be your claim statement. And when we're working on the null hypothesis, mean is always equal. Okay, null hypothesis, population mean equal to 14.3. Now, think about it. What is your alternate hypothesis? Will be strictly less than, strictly greater than, or not equal to. It should be strictly greater than, right? Because they say the nursing staff at the hospital has increased. Okay, will be increased, so it's going to be greater than. And this is going to be white tail test. Okay, prepare. State the two conditions. The sample is random and independent. Sample size will be 35. So this is good. Okay, number 3, let's find the test statistic. Okay, this is going to be sample mean minus the population mean. Okay, that will be from your null hypothesis. Okay, the mean not will be from your hypothesis. So you should have this guy. I want you guys try to put in your calculator. Okay, when you put it in, make sure you put the parenthesis here. Parenthesis here. You should get 2.16. Okay, number 4, interpret and conclusion. So the 2.16, the test statistics is say here. And then we will be using calculator to find the p-value. You should get the p-value equal to 0.0187. And then we're going to compare with your significance level. Significance level will be 0.05. So it's going to be less than or equal to. Okay, since the p-value will be the area of the white tail here. And this is going to be less than the significance level. So we believe that significance level is going to be here. Okay, 0.05 is talking about the whole white tail here. Okay, p-value is talking about here. So p-value less than the significance level. So we reject it. And then now we're going to draw the conclusion. There is sufficient evidence to support the mean experience among the nursing staff has increased. Okay, let me show you guys how to use your calculator. Okay, first, let me show you guys how to plug in this part into your calculator. I'll be using the preference 18.37 minus 14.3. Okay, cos preference divided by another preference 11.12 divided by square root of 35. And then we have a 2 preference here. Okay, enter. So you're gonna get 2.16. Okay, here it may be 2.17 if we wanted to 2 decimal space. But let's try to check on your calculator. Go to the test. And then we're gonna go to the t-test. Okay, go to the t-test. T-distribution hypothesis testing. We have the statistics summary. This is the null hypothesis. So that will be 14.3. Sample mean 18.37. And then sample standard deviation, sample size 35. And then we have greater than. Alternate hypothesis is going to be greater than, and then calculate. Enter. So you can see we have the test statistic 2.165. Okay, so let's try to make it like 2.17 here. And then this is going to be the p-value 0.0187. Okay. Okay, right? So now let's try to do another example. In the 2010 season, average home attendance for NHL hockey games was 70,072. Suppose a sports statistician took a random sample of 30 home hockey games during the 2014 season and found a sample mean of 18,104 with a standard deviation of 1,203.5. Can we conclude that the mean attendance and NHL games has changed since the 2010 season? So first, find the null and alternate hypothesis. We are working on the population mean, so H0 will be equal to 17,072. Okay, how about the alternate hypothesis? They say they want to see it has changed, right? Change. So that would be not equal to. So we have to tell. And then we're gonna prepare the condition, two conditions. Random and independent. Second one, large sample size, right? N is equal to 30. Okay, plug into the formula to find the test statistic. You should get 4.7. We have a two tail, so t equal to 4.70 or t equal to negative 4.70. And then we use a calculator to find the p-value, which is really small here, okay? Compare with your significance level. And it makes sense, right? Because the test statistic is really big in here. And then the p-value talking about the area of this part. So it's almost equal to 0. And since p-value is less than the significance level, we're going to reject. And then draw like the significance level here. Total is going to be 0.05. But we have a 2 tail, so we're going to be divided by 2. So each tail is going to be 0.025. Okay? And then draw the conclusion. There is sufficient evidence to support that mean attendance at hockey games has changed since 2010. Okay, on the exam, I need you guys finding the test statistic using the formula. You can use your calculator to double check your work, but I need to see this work. And also, I need to see this picture as well. You can use your calculator to find the p-value, okay, but make sure you're gonna compare with your significance levels. They reject or fail to reject. And at the end, draw the conclusion. That's it.